everyone, it's Justin again. At this point, we've already learned what functions are, but what about graphing them? Will they look different from equations? How can function graphs be used to find values? Well, let's find out. Let's take this function and graph it. I'll give you an input, you tell me the output. Ready? What's the output if the input is -2? 3 times -2 would be -6, plus 2 would be -4. How would we graph this, though? The key is the axes. With equations, the axes always represented x and y, but with functions, the x becomes whatever the input is, and the y becomes the function's output. So if we want to graph that when the input is -2, the output is -4, we use the horizontal axis to find where the input is -2 and find where the output is -4 along the vertical axis. Then we plot a point at that spot. In short, instead of the points having x, y coordinates, they have input-output coordinates. Let's plot a few more points then. If the input is 0, what's the output? Well, 3 times 0 is 0, plus 2 is 2. Input 0, output 2. So then our point would be right there, at 0 horizontal and 2 vertical. What about when the input is 1? 3 times 1 is 3, plus 2 is 5. So our point showing that an input of 1 creates an output of 5 goes right here. We're starting to see a pattern here. Any input we use will give an output along this line. So if we wanted to know the output for an input of -1, we'd look on the line and see this point here, showing the output as -1. The function we just graphed is called a continuous function because it creates a continuous, smooth line that never breaks and has an output for every possible input. The opposite is called a discrete function. In a discrete function, only certain input-output pairs are known, but not what happens in between them. The graphs of discrete functions often look like scatter plots. For this discrete function, we have to use the graph to evaluate outputs. We can locate where the input is -3, right here, and the point shows us the output is 4. We can also tell that for an input of 2, the output is -1, or that an input of 5 gives an output of 1. However, we have to base everything on the points. For instance, if we wanted to use an input of 2.5, we'd be out of luck because there's no point with an input value of 2.5 here. See if you can answer this before I do. What's the output for an input of 3? For an input of 3, the output is -2. What about for an input of -1? Input -1, output 0. What if 0 is the input? This one's a little harder to figure out, but it's halfway between 0 and -1, so it'll be -0.5. Time for a discrete example. For an input of 0, what's the output? The output would be 4. What if the input is -1? For an input of -1, the output is 1. Finally, what's the output for an input of 3? An input of 3 gives an output of -2. Reading a function graph is just like reading the graph of an equation, but it doesn't hurt to practice. In the next video, we're going to use more graphs to discover what input is required to get a specific output. See you then.